Okay, so in this session we are going to have a walkthrough to our library. Let us see what exactly the .lib looks like, what it contains. We have already seen in our theoretical sessions how what is a .lib, and .lib is like a collection of our standard cells, and it contains slow cells also, fast cells also. All these things we discussed, correct? So let's have a feel of what the .lib is, what it contains. Okay, so our libraries are in this area. So I'm going to open our Sky 130 library. Okay, so first let us understand the name of this library. Okay, so it's going to open something like this. So to have a pleasant color, I'm just going to do this. You can say, you can also do this in case if you find this red color to be irritating. You can do, after opening it in GVim, you can say shift colon and say syn off. This is syntax off. So it will switch off the syntax. Now let's see. So the library starts. Kindly don't edit this file. Okay, this is just only for understanding purpose. I request you not to edit this file. This is very important. Okay, so the first line tells you the name of the library. It is the Sky 130. This is a 130 nanometer library, and it is FDSCHD TT. TT stands for typical. Okay, the libraries can be a slow, fast, or typical libraries. So TT is talking about the typical, and you say 025C. 025C is the temperature. These are very, very important things we need to pay attention to. So there is something called as, when you look into the library, there is a 3-word coming into picture, 3-letter word. It's PVT. P stands for process, V stands for voltage, T stands for temperature. Okay, these three are very, very, very important for a design to work. Okay, let us try to understand what exactly we mean by that. See, process, there will be variations in process. Okay, process. Why? Because fabrication has variation. So variations due to fabrication. Okay, variations due to fabrication. Okay, that is, when you're designing, see, it's very simple, guys. Say for example, you're going to do some task repeatedly. You cannot every time repeat the task in the same way, correct? Say for example, think about this. Let's say for example, you guys are baking a bread. Can you say that every time you bake the bread will get roasted in the same way? Somewhere you will find some places where the say you're toasting a bread. Some places it gets toasted more, some places it's not getting toasted more, correct? So it's same thing. So any task when you keep repeatedly doing, let's say for example, you are cutting a paper. Every time you cannot cut the paper exactly along the same line, correct? So there will be some variations that is happening. Similarly, there are going to be some machines which is going to fabricate your transistor, and that machine will have some variations, correct? It cannot exactly dot to dot do the same thing again and again. There will be some variation that is going to create some process variation. And then there's going to be variation due to voltage. This we clearly understand. Voltage, because if when I vary the voltage, there is definitely going to be a variation in the behavior of the circuit. And then temperature. We all know semiconductors are very, very sensitive to temperature. So the process variation, voltage, and temperature, all these three together determines how my silicon is going to work. This can tell you whether the silicon is going to work faster or slower or all the, and when you want to make the silicon work, you want to make the silicon work across all the corner. When temperature varies also, you want the silicon to work. When the voltage varies also, you want the silicon to work. When the process varies also, you want the silicon to be working. See, very simple. Let's talk in very simple terms. Let's say for example, why temperature? Let's say for example, let's take some example. Let's say you are making a product, some product. Say for example, let's say you are making a CD player. Now the CD player will be sold in different parts of the world. Let's say for example, you're selling a CD player which is getting sold in Switzerland. The same thing is getting sold in Dubai. and the same thing is getting sold in India. So wantedly I'm picking 3 places having different temperature. In Dubai, always the temperature is greater than 30 degrees. And it goes as high as 50 to 55 degrees centigrade also sometimes. Correct? In Switzerland, the temperature is always less than 20 degrees. Sometimes it goes to minus also. In India, some places it is different. And in these places also, in the month of March, it is different. In the month of January, it is different. In the month of December, it is different. In the month of May, it is different. In day, it is different. In the night, it is different. Correct? But across all the places, across all the time, you want your circuit to work. Correct? Correct. So we need to factor in these variations while we are designing our circuit. So our libraries will be characterized to model these variations. So this temperature, this voltage and this process is what is indicated in the first line. If you see TT indicates a typical process, 25C indicates the temperature, and volt 1V8 indicates the voltage. Okay.